Alright, Algebra 2 Trick Honor students. So today I would like to go over the midterm study packet. So the first part of the midterm study packet. So to look at that, the number 2. So again, all the even number. So this one is all about the binomial expansion. So anytime that I see the binomial expansion, you want to start it off with the Pascal triangle. Okay, so it's all the 1 outside, and then so it's 1, 1, and then 1, 2, 1, and then this one would be 1, 3, 3, 1, and then the next one would be considered 1, 4, 6, 4, 1, all that. So the power here, so the power started with a power of 0, okay, x plus y to the power of 0, and then x plus y to the power of 1, and then the next one, x plus y, quantity to the power of 2, and then for the third one, then that'd be x plus y to the power of 3, and then this one here, then that'd be x plus y to the power of 4, and then if you keep going, then that'd be 1, 5, 10, 10, 5, 1. So x plus y to the power of 5 for the power expansion. Okay, so anytime they see the power expansion, so for the fifth power, so that means this one is written as 1, 5, 10, 10, and then 5, 1. Okay, so 1, 2, 3, 4, 5, 6 term. It's always greater than the power by 1, so 6 term. So started off with y to the power of 4, quantity to the power of 5, and then the next term, then that'll be considered 5 times y to the power of 4, and then to the power of 4. As you can see that it's always 1 degree less compared to the previous power. And then for the second term, you want to raise up the power by 1. Okay, so let me just get some space here. So this one is 10. So the next one is 3x, quantity to the power of 1. And then what about for the 10, the coefficient 10? So coefficient 10, so let me bring down the other 10 right here. So the other coefficient 10, so that means it's going to be y to the power of 4, quantity to the power of 3, and then 3x quantity square. Okay. And then for another 10, again, this one, for y to the power of 4, the degree is going to be 1 degree less compared to the previous one. So y to the power of 4, quantity square. And then at the same time, for the second term, for the second element, so 3x quantity to the power of 3. And then plus 5 times, because that the coefficient here is 5. So 5 times y to the power of 4 to the first power times 3x to the power quantity square. And then for the last term, obviously, it's going to be 1 times 3x quantity to the power of 5. So for the binomial expansion. And then the rest of this, you want to multiply it out. So y to the power of 4 to the power of 5, y to the power of 9. And then the rest of this, simplified it. Okay, so now let's try another one. So again, so we're using the 6th row right here with the 5th power. Okay, so again, it's 1, 5, 10, 10, and then 5 and 1. So started off with 2x to the power of 5. So 2x quantity to the power of 5. And then plus 2x quantity to the power of 4 times 3y to the power of 3 to the first power, and then plus 10 times 2x, once again, quantity to the power of 3. Again, the power for that 2x is always 1 degree lower from the greatest power to the least. So 2x quantity to the power of 3 times 3y cubed quantity square, and then plus 10 times 2x quantity square times 3y to the power of 3, the whole quantity to the power of 1. Well, to the power of 3, excuse me. So anytime that I see the second element, always raise up the power by 1 after you expand it. So 5. Okay, let me just put that one down the bottom. So plus 5 times the quantity of 2x quantity to the first power times 3y cubed quantity to the fourth power. And then the last term is just 3y to the power of 3 quantity to the power of 5. And afterward, make sure that you need to simplify the whole thing. Okay? So for the Pascal triangle with the binomial expansion. And then determine the number of terms n in each arithmetic series. So the value of n, well, this one, it's arithmetic, so we're using the properties of sigma. Coefficient, we can always plot the coefficient, so 4 times sigma, k equals 1. So for k equals 112. We can certainly divide it by 4 first. So that means sigma equals, starting with k equals 1. So 112 divided by 4. Then we'll get 28. And then after that, you want to expand it. So this one is just like a basic arithmetic series. So that means n plus 1 over 2 equals 28. And then from there, you want to solve for n. Okay? And then the other one is quite similar. So this one, it's a binomial, so we want to expand it out, separate them. So 9, again, coefficient, we can always bring it to the front. Minus, well, 16 sigma. So that means like 16 times n. So this one is written as 16 times n because you want to add 16 n times. And then this one is just 9 times the quantity of n, and then n plus 1 over 2. So once you combine them, and then try to isolate the variable, well, it looks like this one's going to be quadratic, so you want to bring everything together to one side. Then solve for n. So for combinations, so it's always what? N choose r. So n choose r, the formula is n factorial over r factorial times n minus r factorial, quantity factorial. So this one is 16 factorial over 10 factorial times 16 minus 10 factorial, which is what? 6 factorial. So try to expand it out. So 16 times 15 times 14 times 13 times 12 times 11 times 10 factorial. So you stop at 10 factorial. The reason why that is because you want to reduce. And then the rest of the 6 factorial, you can multiply it out. 6 times 5 times 4 times 3 times 2 times 1. And then just cross cancel and find out what that is. So this one is quite similar. So 22 factorial over 4 factorial times 22 minus 4, 18 factorial. And then you want to expand it. So state each of the scenario involves a permutation or combinations, then find the number of possibility. So 14, Ming has homework in 5 subjects, and she's deciding what order to complete them. So anytime that's considered what order to complete, what order to follow, so that means it's considered permutation. And also the way to come up with the possibility, then that would be considered 5 times 4 times 3 times 2 times 1. Or you can just say that it's like 5, pick 5. Okay, so 5 factorial over 5 minus 5 factorial. Okay, so just multiply them all together. And then the other one, So Perry has homework in 6 subjects, so he's deciding what order. So this one's quite similar, so permutation. So 6 times 5 times 4 times 3 times 2 times 1. Now what about the odd number? So this one, the student body of 55 students want to elect 4 representatives. So this one, order does not matter. Combination. So 55, choose what? 4. And then the other one is quite similar. So you want to find out the order matters or the order does not matter. If order does matter, that means permutation. Order does not matter, it's combination. So find the number of possible outcomes in a sample space. A spinner can land on either red, blue, or green. And you spin 5 times. So either red, blue, or green. So 3. And how many times? So 5 times. So 1, 2, 3, 4, 5 using the fundamental counting principle. So 5 times, so 5 blanks. So each time we do have either red, blue, or green. So 3 times 3 times 3 times 3 times 3. Or it can be done by what? 3 to the 5th power. And here's another one. A pizza stands offer both hand toss and, hand toast, and pan pizza. So customer can add any combination, can add any combinations of 7 available topping. Okay? So this one would be 1, 2, 3, 4, 5, 6, 7 different topping. Now, what about if the customer does not want to add any topping? So that would be the extra one. Then that would be 8. And so this one, so it's both either hand toast, and pan pizza. So that would be considered what? 2 times 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 2. So then that'll be 2 to the power of 8. So the extra blank that I put in here, it's the one that the customer doesn't want to add any topping. So sometimes you'll see the tricky problem like that. Okay, so the rest of this, it's all about the the synthetic it's all about the synthetic division. Okay, so let's do one of the complicated one. So we got 10, negative 31, 5. It's all about the matter of setup here. So you've come up with the setup correctly. That means the rest of those is pretty straightforward. So 10, negative 31, 5, 21, 16. And it looks like the quadratic, x squared is missing. So 0, negative 34, 9. And the one that we have to divide here, so you said that divisor equals 0. So we do have x equals 3/5. Okay. So now you want to find out the remainder. So 10, bring it down. So 10 times 3/5. So 2 times 3, then that'll be 6. And then 6 plus negative 31, then that would be considered negative 25. Negative 25 times 3/5. So then that'll be negative 15. Plus 5, then that'll be negative 10. And then negative 10 times 3/5. So negative 6. Plus 21, then that'll be 15 again. 15 times 3/5. So then that'll be 15 times 3/5, then that'll be 9. And then 16 plus 9, then that'll be 25. 25 times 3/5, 15. And then 15, bring it down. So 15 times 3/5, then that'll be 9. Plus negative 34, then that'll be negative 25. And then times 3/5, so then that'll be negative 15. Final remainder, then that'll be negative 6. Okay, so again, whatever the quotient, the coefficient that you have for the quotient, make sure that you need to multiply by the denominator, which is 1/5. So multiply all the coefficient by 1/5 eventually. Remainder, just rewrite it. So eventually it's going to be considered 2x to the power of 6. And then minus 5x to the power of 5. And then after that, negative 10 times 1/5, negative 2, x to the 4th power. And then plus 3, because 15 times 1/5, 3x to the 3rd power. And then plus 5x squared. And then plus 3x minus 25. And then plus the remainder over the divisor, so negative 6 over the original divisor, 5x minus 3. And a lot of people might be wondering, why do I need to multiply by 1/5? Because the divisor that you have, it's considered 1 over 5 times the quantity of x minus 5 over 3. 3 over 5, excuse me. As you can see that the divisor is what? 3/5. So 1/5, so that one is just considered the greatest common factor. So what about the nonlinear one? The nonlinear one, so you have to use the long division. The divisor is considered nonlinear, so you have to use the long division process. And now what about 25 to 28? So 25, 28, just solving the exponential equation. So again, this one you want to come up with the common base. So the common base here would be considered 4. So 4 to the power. Well, basically this one here, the first one is actually quite obvious. So before you come up with the common base, and guess what you can do? Cross out that 64 to the power of negative 3r. So we got 1/4 to the power of negative r, so that equals 1. And then you solve for r, so r, this one would be considered 0. And then the other one, so 243 to the power of n plus 3 equals 1, because 81 divided by 81, that's 1. And then for those you might be wondering what n is, so n for this one would be considered negative 3. And then 30 to 32, so this one, what happens if I do it without using a calculator? So the way to do it without a calculator, so this one you want to add 2.8 on both sides. So it's 5.6 equals, well, 5.6 e to the power of 4 minus 10n. So that equals 43.8. And then divided by 5.6. So e to the power of 4 minus 10n equals that ratios right there. And then the rest of this, you want to take the natural log on both sides. So once you take the natural log on both sides, this one turns out to be 4 minus 10n. So that equals natural log of 43.8 over 5.6. So natural log of this quantity. And then from here, you want to isolate the variable. And what about 34, 33 to 36? So this one's all about condensing. So difference to quotients. So natural log of x plus 3 over x minus 4. So that equals 4. So take base e both sides. So we do have x plus 3 over x minus 4 equals e to the power of 4. And then this one here you want to cross multiply. So e to the power of 4 times x plus 3. And then, so that equals x minus 4. And then from here, you want to collect the like terms. So once you collect the like term to one side, you can solve for x. So expand it. So e to the power of 4, that's a coefficient, plus 3e to the power of 4. So that equals x minus 4. So take that x term together to one side. And then take out the greatest common factor, x. And then from here, you want to solve for x. Okay, so make sure that, the value got to be considered the valid solution, not the extraneous. So for the rest of this one, so this one here, 37 to 40, it's all about finding the rational or the imaginary root. So state the number of complex root, the possible number of real and imaginary root, and the possible rational roots, p over q, and the interval in which all the real roots lie for each equation, then find all roots. So this one is quite obvious. So either 4 real roots or 2 or none or 0. And then for the imaginary, same thing. So for the imaginary, could be either 4 real. Well, because none of those are real, that means all 4 of them would be imaginary. Or 2. It's always less than a number by 2. 4 imaginary. 2 or 0. And now what about for p over q? So p over q, so we'll just put it in. So negative 4 over 1, so what are the possible roots? Plus minus 1, plus minus 2, plus minus 4 over plus minus 1. So basically just the same number. Plus minus 1, plus minus 2, and then plus minus 4. And then to find all those real roots. Well, this one is factorable. So x squared minus 2 times the quantity of x squared plus 2. Difference of 2 squared pattern. And then for this one here, you want to factor it again. So x minus root 2, x plus root 2. And then the other one is like x minus root 2i. And then x plus root 2i. Imaginary solution. So for those real root, we do have x equals plus minus root 2. Imaginary, we do have x equals plus minus root 2i. So again, anything that's factorable, there's no need to use the synthetic division. So you see that the majority of this looks like they're factorable. Well, even for the quadnomial, you can always try to factor by using factor by grouping method. So that's another strategy for factoring. So here's another one. So try to factor with the smiley face. Let's just state the number of real roots. So it could be either 4, 2, or 0, just like the previous one. Imaginary, same thing. So 4, 2, or 0. And then for the rational roots, so just like the previous one, p over q. So 4. Well, this one, that's going to be a lot. So 48 over 1. So plus minus 1, plus minus 2, plus minus 3, plus minus 6, plus minus 8, plus minus 12. What else? Plus minus 16, plus minus 24, plus minus 48. That's a lot of possibility. If you try to factor, so we got x squared. 48, we do have negative 6, negative 8. So x squared minus 6, x squared minus 8. Set it equal to 0, solve for x, so x squared equals 6, so that means x could be plus minus root 6. And then the other one, x squared minus 8, so that means x squared equals 8. So x equals plus minus 2 root 2. Okay, so now let's see what else. And then for number 41 to 44, so that one is solving for the rational equation. So we'll talk about that for the second part of the video and the rest of this. Okay, so see you guys next time.